All right, thank you for taking the time to join us today. We're kicking off 2025 with a conversation about AI and cybersecurity. This is probably not a surprise to anybody who's paying attention right now to both the macro landscape and the state of cybersecurity as well. I would say even, if you look within the cyber bubble, AI is also probably the most prevalent topic over there. And thankfully, I'm joined by somebody who's got a little bit more experience, depth, wisdom, breadth, all of it actually, to shed some light on today's conversation. Sounil Yu, former chief scientist at Bank of America, co-founder at Knostic.ai, author of the Cyber Defense Matrix, creator of the Triad. I mean, the list goes on and on. If you've seen Sounil on Modern Cyber before in the past or listened to him, you probably know all of the accolades he's earned over the course of his career. But Sounil, thank you so much for taking the time to join us today.
Thanks for having me, Jeremy, and Happy New Year for everyone.
Yeah, Happy New Year indeed. Well, so let's talk about what do we think has changed over the last year or so? Because we had a conversation about a year ago about AI. And again, you can go back and find that on Modern Cyber. And I want to kind of just start by checking in on, what motivated you, first of all, to start looking at the intersection of AI and cybersecurity?
So actually, first of all, what motivated me was to think differently about how we use the word security to begin with.
Okay.
We oftentimes, the word security compared to, let's say, the word safety.
Yep.
And AI safety is something that a lot of us should be concerned about. And if I were to look at the word safety versus security, you may wonder, what's the difference between the two? And to distill it into a quick nutshell, if you were to put the word food in front of these two words, it actually helps us distinguish the difference between the two. Food security, what's that about? Well, that's typically the government's job. It's somebody else's responsibility. And it's something that we don't necessarily have direct control over. Food safety is something that we all have personal responsibility for, and something that we can take on and tackle ourselves. You wash your hands, you segment your food, those sort of things. Well, when it comes to cyber security, I would argue most of what we actually do is cyber safety. And to that end, I think there's a very close connection between what we do in cyber safety and the needs around AI safety. To put it more poignantly, I would say I would rather invest, for every $1 I invest in AI security, I would rather invest $100 in AI safety, because I would much rather have a insecure but safe AI system than a very secure but unsafe AI system. Think about, actually, let's use a car as an example. Would you rather have a insecure car, but an insecure but safe car, or an unsafe but very secure car?
Yeah. No, I can totally see the trade-off there. But I guess just to kind of dive in on a little bit of what you said there about, let's say, AI security versus AI safety, if we think about that, the things that come to my mind immediately around what is in AI safety is probably things about, the content that either goes into or comes out of these AI systems. Is that kind of the line of thinking that you have when you say AI safety as opposed to AI security?
Well, that is one of the concerns that people have, especially with LLMs and generative AI. It's more around the toxicity of that content and whether it creates harm in a way that people may feel triggered or may feel like they're being diminished or whatever else it is. But that's not, in the grand scheme of things, that's a different type of safety than the kind of safety that most people would be concerned around, which is physical safety or actions that an AI system takes that causes loss of human life. If an LLM spits out a recipe for a bomb, someone still has to go and build that bomb.
Build the bomb,
that, right?
Yeah.
So it's a slightly different definition of safety. That you don't necessarily want to give people the recipe for how to build bombs or biological weapons and that kind of stuff. But at the end of the day, that's a smaller issue compared to an AI system that is also in control of a weapon system that goes awry.
Right. So in fact, a lot of the safety is about, where are we implementing AI? Is it in connection to systems that have material impact on, human safety, physical safety, food safety. I mean, critical infrastructure systems. I could see a lot of applications there. And I do know that there are a lot of companies talking about things like, hey, could we use AI to do better water management? Could we use AI to do better management of the application of fertilizers, which might have toxic materials or potential toxins to the human system if they're not processed correctly and so on. So I get what you're saying there. Yeah.
And one of the things you asked earlier at the start of the conversation was, what has changed over the past year? What have we learned?
Yeah.
And I think what I would say is what we've learned over the past year is, as whenever a new technology comes in, it's hard to anticipate second-order effects and emergent properties from these systems. And I think we're starting to get a glimpse into some of these. And I don't think we understood all of them. But I'll give you an example. As you know, everything has an API, and many of the agentic AI systems that we're seeing starting to emerge will basically interact with these APIs. Yeah. And what we're starting to see, and what we should continue to expect, is to see agent failures that emerge where the business or the agent owner just has no freaking idea why the failure occurred.
Yeah.
It's a gigantic, complex adaptive system, and these types of systems are really difficult to predict ahead of time how they're going to fail. We've used principles like chaos engineering to figure out where these failures may occur, but I don't think we've really figured out how we're going to determine where those failure points are when it comes to AI systems, because they are very non-deterministic in nature, whereas at least with non-AI systems, they're at least a little bit more deterministic. We can repeat some of these patterns and see where the failure points are, but with AI systems, because they tend to be more more random. Yeah. When a particular failure occurs, sometimes it's not a repeatable failure.
Yeah. And I would say, in addition to being a little bit, let's say more random, to use your words, I think one of the things that a lot of organizations that I've talked to struggle with is the fact that they're very black box, right? Mm-hmm. Generally speaking, unless you're a very large organization that has the capability to say, either buy an off-the-shelf commercial model that you kind of own in-house and have the right to inspect the underpinnings of, or you have enough resources to go grab one of the open source models like Meta Llama, but then actually devote people to go in and inspecting it and trying to kind of reverse engineer how it arrives at its conclusions. Most people are going to be taking models off the shelf as is, and they're not going to necessarily understand how the output gets generated. They know how to feed in a prompt. They know how to, accept a response and then perhaps act on that response. But they don't necessarily know, how the sausage gets made, so to speak, in the middle. And that's one of the things that I think is probably causing some kind of, I won't say consternation, but definitely people having to adjust their strategies. Most of these new technologies that get adopted, I agree with you completely that they have second order effects that we can't predict, right? Who knew that, for instance, the widespread adoption of cloud technologies would lead to this huge rise in accidental exposures of data sets through, exposed S3 buckets and RDS databases, right? Like, we didn't know that, configurations were going to become one of the main kind of security controls on those systems. But similarly, you could go and look at all of the documentation and all of the technical controls and understand, okay, this is the mistake I made. I think with LLMs, I think it's a lot harder for organizations to understand, why did I not get kind of the anticipated output?
Yeah. And I think the unpredictability of these LLMs will end up creating some degree of consternation, or continue to create some degree of consternation around what the expected outcomes are. But generally speaking, I would say statistically, we can at least understand the rate of failure and safeguard against that. I mean, we don't know when systems are going, like stress fractures in metal. We don't know when it's going to fail. But we have a statistical probability of when it might fail. And when it does fail, we have other controls that safeguard against that particular point of failure. So I think we have to look at it from that sort of standpoint and create the appropriate margins of safety around these systems as well.
But that really implies, I think, a need for rigidity or not rigidity necessarily, but a need for like pretty thorough and exhaustive testing and anticipation of what those failures might be. Yeah. And I don't think that I see a ton of that happening right now. Either, again, for lack of resources or perhaps lack of understanding that this might be an issue that pops up in your AI adoption.
Yeah, and I think the more going back to the notion of complex adaptive systems, we don't do chaos engineering when it's a complete black box and you don't know what type of failures, how to pinpoint failures when they occur. If we start to do this type of testing with AI systems, it really has to be done incrementally so that we know that when something does fail, we've safeguarded against those particular failure points. If we try to do this across multiple AI agents and AI systems, failure could happen anywhere in that pipeline, and we just don't know where it's gonna. It'll be really hard to unpack that.
Yeah.
So anyway, yeah, I think in the grand scheme of things, that's something that we should anticipate for the coming year as we see more failures occur, and people are going to scratch their heads trying to figure out, okay, what just happened.
Yeah, yeah. And we should stress there is an upside here, right? Like this isn't all, let's say, oh, there's all this complexity, there's all this unpredictability, there's all this training and resource allocation required to get positive results out of these systems. Just like we were talking about kind of unexpected second order effects, I would say when Microsoft introduced what the concept of web services in the early 2000s, going back, quite a ways, SOAP and XML, for those who have had to bang their head against the walls with those technologies. And I know many organizations still continue to use those in systems. Could you have predicted at that time that it would really unlock this entire internet ecosystem of things like, let's just say like an online travel site that allows you to, build an itinerary that then goes and books on your behalf, flights, hotel, transportation, rental cars, etc., in one transaction, but isn't actually a part of the airline, isn't part of the hotel, isn't part of the rental car agency, but through all that interconnectivity is able to do all of that. I would argue, like, probably at that time nobody had the vision that would be something that became a possibility as a result of that.
Sure, but I think let's separate out second order effects from what maybe in your case like third order, fourth order.
Fair enough.
Let's look at the second order effects first. And to say, okay, when web services came about, we had to think differently about the architecture of applications in general. And these applications need to be built in certain ways, or we start reevaluating our assumptions around how applications should be built. I'll give you an example of a more direct second order effect when it comes to AI, and then we could talk about third order effects beyond that. So the most clear, here's a perspective that we kind of generally know. Speed, quality, cost. Pick two. Or maybe one. Okay.
Yeah.
But what if you could pick all three? Okay.
Yeah.
What if you could pick all three? What if you can get speed, quality, and cost because of AI? Well, what that means is that there are assumptions that we've made where because we can't get all three, we've had to make certain we've made some trade-offs. Okay. I'll give you a simple example. Open source software. Open source software is supposedly more secure because you have more eyeballs on it, right? We can it's too expensive, for example, to have, or rather, just because you have more eyeballs who can look at code and pick away at it, you can end up having more secure software. But what if our eyeballs are instead machines? Okay. Could you actually make an argument that closed source software would be more secure now?
Yeah.
So there's a fundamental assumption that we're making that was popularized in the Cathedral and the Bazaar, that the book that's open source software. All sufficient eyeballs makes all bugs shallow. But if you have sufficient eyeballs through AI, then could we actually see in 2025, 2026, more secure software because it's actually not exposed to the public, but it is exposed to a whole bunch of internal machine eyeballs? Yeah,
that's a great point, and I the part of the kind of, let's say, mediator in me wants to say there's arguments on both sides, for openness and for security of systems that don't expose all their potential flaws for every coder in the world or every AI code scanner in the world to go unpack and find these kind of problem points. But I do think organizations have to pick a strategy that works best for them And I think very often based on the resources and the reality of the situations that they have, right? I mean, it's a little bit the question that a lot of customers face when it comes to build or buy. Many solutions, many pieces of software could be built, right? And a lot of them, there's this classic trope that I'm sure you as an entrepreneur have also heard, that the vast majority of solutions are replacements for a Microsoft Excel spreadsheet, right? And so anybody could build a solution internally to build that spreadsheet and maintain it if they choose to prioritize that, if they choose to allocate the resources for that. This is maybe not true in every situation. And by the way, certainly not true in the case of LLMs. Yeah, I would argue almost no organizations, aside from the ones that are actively publishing them, have the data sets, have the capabilities, et cetera, to do that. But in any fact, anyway, the point is I totally get your argument on both sides of this thing. And I do think organizations have to make a realistic decision for themselves.
And I think the one of the things that has really changed, or at least what we should be thinking through in the near future, is really understanding what things have become machine scale that we haven't realized is actually machine scale. Let me give you another underlying assumption that we oftentimes still hear. You don't need to be faster. You don't need to outrun the bear. You just need to be faster than the person next to you to outrun them.
Yeah.
Right?
Yeah.
Okay.
Yep.
That's a human scale argument. There's only one bear, and they can only chase one thing. Therefore, if you run faster than everyone else, then you're good. But we now have the attackers have the ability to do machine scale digging through stolen content. You now have the opportunity for multiple bears to chase pretty much everything that's out there, and so it creates the challenge for all of us to say, okay, how do we stay ahead of all these different bears? Because it's not just a single bear. It's not just a single bear where you have to outrun your neighbor. It's every bear that's coming after you. And so the manifestation of that is coming through, for example, the breaches of all these third parties, national and public data, or I think I just recently heard there was a whole bunch of location data that was compromised, or there's a lot of different things that are now widely available for attackers to process at machine scale. And they no longer have to make as many trade-offs in who to pursue because it's much more readily parsable and discoverable.
Yeah.
And at some point, they'll quickly find ways to automate those attacks as well, and we'll see some interesting things.
This is something that I think, those who have been in security for a while would tell you this, and I'm sure you've heard this yourself and probably even kind of preached this to certain organizations. I mean, number one, everything starts with visibility. If you don't know that it's there, then it's always a problem or a potential blind spot for you. But number two is hackers have automation and hackers have access to cloud. Just, they might be using a stolen credit card to do that, but they have access to many of the same tools that we do. So you should think, of your adversary as being pretty well equipped, right? And I do think that there's enough evidence of jailbreaking LLMs for various use cases that do pose serious risks to organizations. And whether that is what was the one that kind of floated around last year was the was it Crack GPT or Dark GPT, or what was the name of it? I'll find it as we're talking here. But effectively, it was a jailbroken version of an LLM that went outside of the ethical guidelines that had been built into it. So, we talked about last time how if you try to ask an LLM to give you a recipe for a bomb or to write you a phishing email, there are kind of ethic guardrails that are built in and it won't respond to it. That's true for every commercial LLM that I know of, and it's also true of some of the major open source ones that I know of. But, with resources and with access to source code, those things can be removed, right? And so, that's something that I do think is along the lines of hackers have access to automation. Hackers do have access to, to resources and to tools that are pretty compelling.
Yeah, actually, in the cases, I don't remember which GPTs you're talking about, but there's a bunch of those not uncensored ones that is what you're referring to. And oftentimes, you actually don't need to have access to the source code or the original training data. You can fine-tune the existing models to remove or try to remove as many of those guardrails as possible. And there's reasons to do that because I think the example that I gave, or part of the reason why I created the company that we have with Gnostic, is to be able to have more fine-grained controls around need to know. If I had a guardrail on how to build a bomb, and the LLM said, "Sorry, I can't tell you that because you don't have a need to know." Well, what if actually my job involves that? What if that actually is my job in a totally legitimate reason, and I need to be able to understand how to do that? Now, would I actually be relying upon an LLM to do that? Probably not. Okay.
Yeah.
But if I needed some assist or needed some help from an LLM, then I would want to be able to use this resource for that purpose. What we lack is more of these discretionary access controls that says, look, if your job has nothing to do with building a bomb, then look, there's not a reason for you to get that instruction. But if your job is, then let's make sure you get it. You get that, and the system has to be able to understand what your role is and what your need to know is. And this is something that every organization, every enterprise will need, because within an enterprise, there are some people who have a legitimate need to know about things like layoffs or about M&A,
Yep.
and others who don't, right? And that differentiation needs to be implemented in these guardrails. Today, it's a one-size-fits-all. You either get it or you don't.
Yeah, and I think that's a real challenge for organizations. So, by the way, Worm GPT and Fraud GPT were two that I just quickly found. Those are the ones that I think I was referring to. Sorry for misspeaking earlier. I want to come back to revisiting some of our conversation from last year and kind of get your take, with, I think it's been 9 or 10 months since we had that conversation. One of the things that we talked about last time was that actually a lot of security organizations had been using kind of not Gen AI LLMs, but had been using various AI/ML techniques for doing things like data analysis at scale, at speed, et cetera. Anomaly detection being kind of a classic use case across, let's say, like UEBA or log analysis and things like that. And one of the things we talked about last time was that we've been having the same conversation for a long time because of unmanageable data sets, but now we're actually at a different scale and a different speed. So 9-10 months on from that conversation, do you feel like that's still the case? Do you feel like it is still, effectively just 9-10 months of progress from that point in time and nothing really has changed?
Okay, let's talk about the different types of AI here. The what you were talking about with I'll call traditional AI with anomaly detection. Is it's still in play, and that's still a very useful technique for predictive analysis and so on and so forth. The fundamental question that we should be asking ourselves, however, with the newer GPT-based AI or LLM-based AI, is to fully so the trivial use cases that most people have seen is the simple summarization. Take some content, summarize it, spit it back out to me in a way that maybe is easy to digest. But that it truly is a trivial use case, and there's no real true. There's a little bit of benefit, but not like the real kind of benefit that we'll see if you take a slightly different approach, which is to somehow look at machine information as a form of language itself. So let me give you I'll give an analogy first, and then I'll come back to cybersecurity. There's been some tremendous advances have been made in bioengineering because we see DNA as a language, right? We've always known DNA is a language of some sort. And of course, we don't quite understand how to interpret it. But if you can take a language and, or rather, if you take something and turn it into a language, then these GPTs are actually extraordinarily good at understanding these languages and predicting things and understanding how things should unfold. So the real challenge for those in cybersecurity who are trying to use GPT capabilities, transformers, then the real question is, how can you see the content that's being generated by these machines as a form of language itself? Are logs a form of language? Not the human readable logs, but the machine
right, but
generated.
the machine readable. Yeah.
Can you construct that in a language? And if you can, then you can do some potentially interesting things. For example, where do we see some language that is different than some type of sentence, let's call it that, that's very different than all other sentences I've seen so far? Because maybe that new sentence or new grammatical construction that this log represents is actually a real anomaly. Okay.
Yeah.
And these are, because I'm constructing it as a language, we typically the old way of looking at predictive analytics is looking at a word at a time. Okay.
Right.
Is this word new versus is this word being used in a different way in a sentence?
Right. New context, new meaning, etc.
Exactly right. And that is what's really truly novel here, is to say, is this, it's not just that is this word anomalous, but rather is it being used in a way that is novel? And if it is, then that actually may point to some novelty that an attacker is implementing, is taking advantage of. And that's the true power of using GPTs in cybersecurity. And I would say, I think we're only just barely seeing the tip of the iceberg on that. I haven't seen too many companies really think of it in that way. But that's the real approach that I will be taking.
Yeah, that's really interesting. There's a couple of other things that I'm kind of curious to get your perspective on in there. And one is about, there's this conversation that we'll hear time and again, which is AI for cybersecurity and then cybersecurity for AI, right? And we talked about kind of the difference of safety and security around that. When it comes to, let's say, what's new with the current generation of AI, primarily being the Gen AI LLM stuff, what's new for cybersecurity or cyber capabilities with these new tools in place? We talked about summarization, and I actually think summarization is pretty valid because a lot of the times I know, even from our own tool, we generate a lot of data that comes in very kind of interesting, that shows interesting data points, but is not necessarily easily readable by a human. Right? We correlate something like, let's say, a GitHub push to a change in code that leads to the introduction of a vulnerability of an API that's now published in an AWS environment, right? I explained it in a way that is much, just now, even that kind of rudimentary explanation of it is way easier than most cyber tools will present things to be. They're going to present them to you typically in a list format, maybe in a Slack push or something like that, that is like, hey, new vulnerability in cloud environment, and not necessarily trace it back to that change in the GitHub environment. Okay, so that's awesome. That's the summarization side of things. But what are some of the other capabilities that you see the current wave of Gen AI bringing to cybersecurity tools or capabilities?
Summarization aside, the real capability I mentioned earlier was can you try to convey cybersecurity language into an actual language, convey cybersecurity telemetry into a language.
Into an actual language, yeah.
And if you can, then that's where you start seeing some amazing new capabilities of seeing anomalies in a way that is very different than the point anomalies that we see today. So again, just reemphasize that. At the same time, I would say there are some shortfalls that we should be anticipating that is helpful to be aware of, so that we don't over-rotate on how much we depend upon these security systems that leverage AI, which, by the way, at this point is pretty much every security company out there. So let's just be clear. Every security company out there has some AI built into their capabilities. The depth of them is it may vary, but they're all going to experience these similar flaws. So one thing that I've noticed, or one thing that I've observed this past year, is that there's this, so Daniel Kahneman has this construct called System 1 and System 2 thinking. System 1 is this fast, intuitive, gut reaction sort of thing. If you've read Malcolm Gladwell, it's this blink, then slide approach. System 2 is very cognitively heavy, it requires a lot of thought and reasoning, and but it's very effortful. Well, LLMs are very System 1 based. Current generation AI is very System 1 based. And because it's System 1 based, there's a lot of flaws, like bias, like overconfidence. These are all things that Daniel Kahneman wrote about in his book, Thinking Fast and Slow.
Thinking Fast and Slow. Yeah. An interesting thing, by the way, like in that book title, a lot of people look at the book title, and because of the way it's laid out on the page, they just read Thinking Fast and Slow. But it's actually thinking, comma, fast and slow, the two types of thinking, the System 1, System 2 in there. Sorry.
Exactly right. And so this fast thinking has all these flaws, and we should anticipate those same flaws when it comes to our current LLM-based systems. What we see emerging from the frontier model providers they claim to have more reasoning capabilities being baked in, which are pretty impressive in some respects. And they kind of resemble System 2 thinking or slow thinking. In fact, if you use ChatGPT o1, you see that it actually is thinking. It's slower, right? It actually is slower in producing an answer. And it's because they've put in these, essentially, let's call them reasoning guardrails. If you will. And these reasoning guardrails still will fail, okay? But because it's still fundamentally a System 1 based system. And as long as we recognize it is a System 1 based system, this fast thinking apparatus, then whatever results we get back from these security tools that use AI, we just need to make sure that that whatever results we get are susceptible to those same failures.
But that's got to be also then true for the tools that incorporate it as part of their, let's say, cyber stack, right? So if you're, going to use this for summarization purposes or for whatever other purpose in your own product's capabilities, you need to think about building in some guardrails. You need to think about building in some testing. You probably need to run some testing, and including some testing at scale, to figure out, what these results might be.
Yeah, and I saw, to that end, I saw this great litmus test, which was shockingly simple and yet profound. It was, do you trust AI to run your calendar and schedule everything in your calendar? And you may recall there were some startups in the past that tried to do this, okay, and they actually ended up failing because no one trusted an AI system to properly manage your calendar, because small little errors could be pretty bad, right? I mean, you didn't, for something as simple as your calendar, for something that, I mean, it's valuable. Your time is valuable, but it's not like driving a car where you can kill yourself with it. And yet we didn't trust an AI system to manage our calendar. Okay, just think about that for a moment. If we don't trust these same AI systems to manage our calendar, what are we really asking these AI systems to do when it comes to other business functions that may actually arguably have greater impact?
Yep. Yeah, this is a great point. I actually just recently, funny enough, signed up for an AI calendar manager to test it out. I have not been happy with the results so far. And this is with arguably, some of the best AI around from a company who I won't name, but it's definitely a company that has access to large volumes of data, large numbers of calendars, and, should ideally be doing better. And so anyway, we digress a little bit, but I want to come back to kind of another topic from our last conversation and see if we still feel the same way about some of the things that we talked about back then. One of the things you mentioned is that, hallucinations are not actually a real problem. They're kind of a headline grabbing problem because they're kind of funny when they occur. But let's say like on a systematic basis. And I think there's an important distinction that I always want to draw when I talk to organizations about AI adoption. I think the thing that I always think about focusing on, it's less about what Jeremy does in his own browser, kind of, chatting with ChatGPT to test things out, or to, I don't know, write me an email to Sounil about setting up a meeting next week or something like that. That's great. But those are one-off things, and these are like individual user types of things. Now, arguably what is much more impactful to a business is when it has a business application that integrates an LLM to address something. And that could be like, the case of just help me analyze all of the information on our intranet so I can ask questions to an LLM that is going to give better answers than me just searching on my own. Fine, that's well and good. But now when I think about things that are more kind of customer facing or external facing, building a recommendation engine, things like that, based on an LLM, like these are things where I see that there are potential more impact around hallucinations. How do you feel about hallucinations now, 1 year on from our last conversation? Still not really a problem, maybe a little bit bigger problem, or no change? What do you think?
I think the challenge I have is calling it a problem at all. I would say it's by design.
Okay.
And I'll give you some just simple examples, biological examples that people can relate to. If you stare straight ahead, what you're seeing is actually a hallucination. Why? It's because you actually have a blind spot in your eyes. And your blind spot that's in front of you is actually filled in by your brain.
Right.
So, believe it or not, it's actually a in some respects, a hallucination. That's why we have all these illusions or visual effects that we oftentimes run into. So is that hallucination a good thing or a bad thing? Right?
Yeah.
Now,
yeah.
So there's another view perspective, which is when you're focused on something and it's grounded, it's called attention. When it's not grounded on something, it's called imagination.
Yeah.
Okay. And is imagination a good thing? Of course, right?
Yeah. yeah.
And imagination is essentially a hallucination.
Yeah.
Okay, so just I'm putting these concepts in place because we need to recognize hallucination is not a problem; it's part of the design. So the question then is, where is that part of the design appropriate, and when might it be not appropriate? And of course, we know it's not appropriate when you're trying to tell something that's truthful and grounded on reality. You would say, okay, what am I actually seeing? What am I supposed to show you here? And we see that we don't want it to hallucinate or imagine new things, but at the same time, you know that you have blind spots in your eyes, and imagine walking around the world where right in front of you, there's a big black thing that you can't see through,
Yeah.
right?
Yeah. Yeah.
That's very disabling in many ways, right?
Yeah.
So there's value in your brain filling in the holes, but if you're not sure if you're seeing a visual illusion, you look at it from a slightly different perspective, and the visual illusions that we all are familiar with make it very clear. Oh, wait, this isn't quite exactly what I thought I'm seeing. So that's a control. We have a control that says, let me just look at it from a slightly different angle. Let me move, over here and just see if I'm actually seeing what I'm supposed to be seeing. And let me blink. And a lot of times when you blink, it resets your perceptions of things. So these are controls that we put in, because we know that the brain is designed to hallucinate and fill in holes and to imagine and so on and so forth. Again, it's a feature, not a bug, is another way to put it.
Yeah.
How do we use that feature appropriately?
Yeah, I mean, it's a little bit back to the system one, system two thinking that we talked about. I think a lot of the times it's designed to create an answer, with a high level of confidence, like we discussed, right? Mm-hmm. So, yeah.
And it comes, and it's this fast thinking is very useful for survival, but it has catastrophic failure modes as well. So we have to engage the lazy part of our brain, the system two thinking, to say, hey, let's make sure that what we're seeing or what we're about to do is actually the right thing to do. It's something that we should do just in any sort of risk management decision. We oftentimes do risk management using system one techniques, and things like cyber risk quantification is a system two technique, right?
Yeah.
It's effortful, but it ends up with much better results.
Yeah. Well, we've only got a few minutes left, so I want to go into rapid fire speed round mode for some of these follow-up questions to revisit some of these topics from last time. So last time, one of the things we mentioned was that, jailbreaking LLMs is actually maybe a little bit of a bigger problem, and prompt engineering with a little bit of, let's say, an informed user who knows how to kind of work with prompts well can lead to kind of intentionally bad outcomes. Do you still see this as being a problem?
It's still a problem. That hasn't been fully addressed. I think there's a bunch of companies that are trying to address it as well. Well, one thing that I've discovered over the past year that was interesting is, we have a lot of jobs for prompt engineering now.
Yeah.
And what's kind of funny is that there's already been a job for prompt engineering. It's called library science.
Yeah.
So you have these I think a lot of librarians have a real potential as being like really good prompt engineers, because what happens is you have somebody come up to them asking a question about some topic, and it's not a really well formulated question. And so what does the librarian do? They help you basically figure out, what exactly are you asking for?
Yeah. And it's interesting. Last time we talked about how, actually one of the main things that, one of the main advantages that attackers have historically had is in creativity and in kind of understanding ways into a system. And so you think about kind of prompt engineering, what's useful in getting good prompts is actually the ability to kind of think laterally, rephrasing questions with an understanding about information structures. And that, to your point, is library science, much more, by the way, than it is traditional kind of software engineering practice, right? So that's a really interesting observation on your side, that there's potentially a really bright future for people coming out of library science who are interested in going down this path. Awesome. Another follow-up question. unauthorized data access, I know that this is still a problem. We probably don't need to spend more than about 20, 30 seconds on it, but I imagine nothing's really changed on this side. And in fact, if anything, I would imagine there's been a little bit of an acceleration of this being a problem as more and more companies have looked to the RAG side and, kind of shared their own data models with LLMs.
Yeah. Yeah. The simple example, and give me another analogy, is unauthorized data access. We all know it's a problem, but it's like a problem around like cars that can only drive as fast as 20 miles per hour. So if you have a car that's only gonna max speed of 20 miles per hour, you may forego things like airbags and maybe even seatbelts, right?
Yep.
But now with LLMs and tools like Copilot and Glean, you can go 100 miles per hour. And
That's
the risk
right.
management decisions that we've made in the past around, we're going to forego this or that because things are moved slow enough. Now it's running at machine speed or a whole different speed, and we have to refactor our decisions on we should actually have seatbelts and we should have airbags now.
Yeah. Another thing from last time, we talked about the DKIW pyramid, and for anybody who's not familiar, please Google it. We won't take the time to go into it right now. But one of the things we talked about last time was that, the LLMs were getting increasingly better at getting maybe up to the I layer in that pyramid, but that W was really still reserved for the human layer. Have you seen any change on this side?
Yeah. So actually, just to clarify, it's DIKW, or data information knowledge.
Yep, my bad.
Sorry.
Yep.
So the thesis being that LLMs have brought into the knowledge age, and have we moved into the wisdom age yet? And I would say no. There's no indication that that the machines are helping us with anything around wisdom at this point.
Yeah, I agreed wholeheartly. We also talked about last time about one of the tension points with any new technology, but with LLMs in particular, because they have such vast amounts of data in them already. And then again, more and more organizations are kind of feeding them with their own data. One of the challenges that a lot of organizations face is how do they approach this from more of a liberal access control policy a liberal access policy or more of a controlled access policy. What have you seen? Because I know you've been working with a number of organizations over the last year. How are most organizations approaching LLM adoption?
It depends on how risk tolerant or risk averse you are to begin with. But I think at the end of the day, we always have to recognize that the power of these LLMs, as much as it accelerates the discovery of harmful content, it also the reason why you're really rolling this out is because it accelerates the speed at which you find useful content.
Yeah.
And that's really the goal, right? People roll this out.
Boost productivity.
Yeah.
Boost quality, boost results, yeah.
And unfortunately, what we're seeing is as you tighten up the ability to access harmful content, you're also restricting the ability to access useful content as well. So this trade-off is not a great trade-off, and that's what's happening today. Because of that, though, I think a lot of organizations are YOLOing it and just saying, hey, everyone, just be good, don't do bad things, and hope for the best. But as we all know, hope is not a great strategy.
No, hope is, when I was getting my MBA, I had a professor who liked to say hope is still not a great strategy. And just kind of had that in there. We also talked last time about kind of the state of regulatory frameworks and so on. And I haven't really seen any updates over the last 6-9 months since we had that initial conversation. Have you?
There's more meat being put around, like things like the EU AI Act, and more clarity around what that's supposed to entail. There's also 42001, which just barely got out of the gates at the beginning of last year. And now I'm starting to see companies get 42001 certification, ISO 42001 certification. So things are happening to some degree. I don't know if a lot of it's just security theater or AI theater at this point.
Yeah.
But things are moving, at least in terms of more awareness of the topic, and at least some concerted effort to try to baseline what's acceptable and what's not.
Thanks for flagging that ISO one for me. I wasn't actually aware of that myself, so good lesson for me as well. Awesome. One of the other things that I want to kind of maybe close on today, actually two things to close on today. Number one is we talked last time about kind of the attacker versus defender advantage. We had that conversation. And I think one of the things that you said that I found particularly insightful was defenders are never the first movers, but builders can be the first movers. Mm-hmm. So I'm curious, as you've worked with organizations over the past year, have you seen builders doing more in terms of, like, let's say, layering in security or considering either security or safety controls to their AI initiatives over the past year?
Not really. Not on the security
Not really.
side. Safety
Yeah.
side, yes. Again, safety has benefits for a number of reasons. I'll just give you a quick example again, using food as an example. If you can be faster at making food if you have a safer environment in which you create that food, right? If it's a messy environment, if it's a very contaminated environment, then you actually it slows you down. But security doesn't actually increase your speed or velocity. In fact, it just kind of hinders it mostly. So when it comes to developers and builders, they don't want to be hindered. And so I don't see security measures being put in place. I do see safety measures being put in place. Now, going back to the first mover advantage, again, builders have first mover advantage. And this is where I was saying with the open source paradigm shift, if we have eyeballs that are machine eyeballs, and we can retain first mover advantage because we have access to the source code that nobody else does, then that actually, I think, moves the balance back over to the defender, where the defender is the only one, again, who has access to the source code, and we can have machine eyeballs on it before any other eyeballs are on the running code from the attacker.
Yeah.
So I think that's an opportunity that really puts the advantage back to us as defenders.
Yeah. Well said. I will add one last thing, which is kind of what I wanted to close on, which is, we talked about all of this kind of like AI and security, but security for AI, I do think is something that organizations need to be a little bit more focused on. There was a recent study out of the Capgemini Research Institution. 97% of organizations who are adopting Gen AI have had a data breach connected to that adoption, whether that's an accidental exposure or, let's say, a set of compromised credentials or what have you. And it looks like more than 50% of these organizations have accrued direct and indirect losses of at least 50 million connected to those events. So, I mean, the impact on there is actually a lot higher than I anticipated. I'll link the research for anybody who's interested in the audience. We've got one kind of final question from the audience to kind of close us out on today, which is, as we look at this, there's so much to learn around how we are approaching AI adoption as an industry. And so the question that came in from the audience is, if you had to give one piece of advice, or let's say one starting point for an educational journey, where would you point somebody today?
Well, if it's around AI, there's actually a ton of resources. And I think Google has released a whole bunch of just getting started with AI. I've also seen, of course, education, whether it's Coursera or the MIT open courses, all that stuff. Okay, all that said, let me actually offer I'll harken back to something we already referenced, but I thought was really interesting that helped me understand AI way better than I've understood it before. So one is that book, Thinking Fast and Slow.
Fast and Slow. Yeah.
You want to know how current generation AI systems work? Read about System 1 thinking, and you'll find that it's very closely matched. And the second book I would point to is a book that I had a chance to read this year called I forget the name of the book. It's called the 5 Breakthroughs in Brain Evolution. I think it's called. It's not called that. Anyway. The name of the book is from Max Bennett, and he talks about the 5 breakthroughs in brain evolution. And what's fascinating about that book is it not only gives us a look into how AI systems that we have today work, but also what to expect in the near future. And
and the book's title is A Brief History of Intelligence, Evolution AI, and the 5 Breakthroughs That Made Our Brains. Just quickly Googled it and was able to come up with it. We'll have that linked as well. Sounil Yu, thank you so much for taking the time to talk to us about the state of AI connected to security, both in security for AI, all of that today to kick off 2025. We'll probably revisit this conversation either later this year or at the beginning of next year for anybody who's interested in paying attention. Sounil, thank you so much for taking the time. For anybody who wants to learn more about you and some of your work, where's the best place for them to go check out?
You can check out my company called Knostic.ai, Knostic.ai. Or visit my website on the Cyber Defense Matrix. So cyberdefensematrix.com. Defense spelled with the American way. And
with an S. Yeah.
Yes, with an S. Yeah. And you can find me there.
Awesome. All right. Thanks again. We'll talk to you next time. Bye-bye.
Thanks very much.